I'm Aryan, and in this today's video, we'll be going to discuss about DHCP and NAT. So let's get started without wasting any time. So first of all, let us talk about what is DHCP and what is NAT in detail. Now, before talking in detail, let's get a brief overview about them. So basically, DHCP and NAT are both the protocols of the network layer, and to be very specific, the control plane in the network layer. So there are two planes in a network layer. One is a control plane and one is a data plane. So the role of both of them are well defined. The role of control plane says that the control plane will be responsible for uh, handling and making all the good routes and finding out the best route and the best basically the path and the channel that will be used for the sending of the data from the source to the destination, sending of the data packets from the source to the destination, and deciding the in between routers. The role of the data plane, on the other hand, is responsible for sending up of these data packets on the route decided by the control plane. So, in brief, the control plane decides the path and the data plane sends the data. Now, if you move about DHCP and if you talk about DHCP in particular, DHCP stands for Dynamic Host Configuration Protocol. It's a network management protocol, and it works on the network layer, and it's a network layer protocol, and basically, to be very specific, a control plane one. Now, it is used in computer networks and for the dynamic assigning of IP addresses to all the new joining end devices in a network. Like for example, there's a network already established, like a local network in my home, and when I enter that network with my phone and with my Wi-Fi on, then I'll be assigned certain IP address to work and to connect to that network. Now, why do we use this? What is the main reason for using this? That DHCP server and dynamic host configuration protocol. So basically, DHCP helps in managing the entire process of this automatically assigning the IP addresses. Now, earlier we used to do it by static. Now, if I go in the Cisco packet tracer, also we get the option of static and dynamic. But going into each and in devices and getting setting up the default gateway, setting up the IP address, setting up the range and the subnet mask is a hectic job, and it is a tiring job to do. Instead, if you connect it to a DHCP server, it is a much easier job and requires much more less effort. So this automation process is genuinely very great. And also, DHCP helps in maintaining the IP address limitation by providing only that IP address which is available to it and not wasting any IP address. So nowadays it is very important. Now, if we talk about the main components of an IP of a DHCP server, so there are certain main components like a DHCP server that holds all the required information and all the addresses, IP addresses uh, that are basically free, and all the data that this IP address is being assigned or allocated to this specific end device and all other things. Then we have a DHCP client. Now, DHCP client is something that receives the information and that asks for a IP address from the DHCP server. It can be anything like a phone, like a tablet, PC, or any other end device that requires IP address to function. Now, DHCP relay acts as a communication medium between the DHCP client and the DHCP server, so that they can communicate with each other. Let's talk about the working of a DHCP server. So basically, DHCP is a four-way process. The connection establishment is a four-way process, but the port number for the DHCP server is 67, and the port number for the DHCP client is 68. Now, uh, as I said, it's a four-way process. The first step is initiated by the DHCP client, and it is known to be said as a DHCP offer request, a DHCP discover request. Now, a client sends a DHCP discover request when it enters the network in order to search for any DHCP server. Like if I enter a local network, my device will send a DHCP discover to find that whether there is a DHCP server available or not. Now, after that, we have a DHCP offer request that is sent from the DHCP server to the DHCP client. Now, whenever the DHCP server receives that request, that okay, there's a discover request, that means there's a new joinee. Uh, that means we need to assign some IP address to this joinee. Now, the DHCP server, every DHCP server that is being present in the network, they send a DHCP offer request to a DHCP client stating that these are the available IP addresses that I am currently having with me, and uh, all of the DHCP server sends the DHCP offer request to the client, and the client only perceives the first request that it gets from the other from one DHCP server. The next request is neglected. After that, the DHCP server, the DHCP client basically chooses from one IP address that okay, this DHCP this IP address is suitable for them, and they can work for it. Now, afterwards, they send a DHCP request message. Now, this DHCP request message says that okay, uh, I want you to allot me this IP address. Afterwards, uh, it is sent from a DHCP client to a DHCP server, and the last basically the last message that is sent, the last request is a DHCP acknowledge request stating that okay, I can allot you this IP address. The DHCP server says that I can allot this IP address to the DHCP client, and I'll map it to my table stating that okay, this IP address is being allotted to you. So that's how the DHCP whole process works, and I'll only repeat the main points. So first of all, there's a DHCP discover, then there's a DHCP offer, then there's a DHCP uh, there's a DHCP request, and at last there's a DHCP acknowledge. So, what are the advantages and disadvantages of this? So, basically, talking about the advantages, there's a centralized management of IP address. We get to know about which IP address is being assigned to which device, and the adding up of new device and the new joinee handling becomes an easier task instead of going for a static option. Now, also we can reuse the IP address. There's no such case like we can't reuse it or we'll get our IP address will get wasted. So this provides a very good upper hand, as there are limited IP addresses available. So therefore, the total number of IP addresses that are required for every task decreases. So we don't ask for more. The disadvantages would be that the IP conflict can occur between the devices, stating that two DHCP client may request for the same IP address for the DHCP server. Now, also the client, there can be an issue when the server is not available, or the in the network, or the server does not have any free IP address. That may be a case of may be a hectic case, or maybe a case of emergency that this device needs to be entertained as there is no such IP address available. Now, talking about NAT. NAT is basically network address translation. Now, what is NAT? As I said, NAT stands for Network Address Translation. It is a technology that is used in the computer networks that basically maps the multiple local IP addresses and the private IP addresses to a public one before the data is being transmitted. Now, uh, so basically, let's say I am in my home environment, and the my IP address, my router IP address is, let's say, 192.168.0.4. So that is the IP address that my device will possess for the rest of the internet. So basically, that would be a public IP address of my device, and I'm connected to that router. Also, the port number would be different. I'll talk about that more on that later. But why to use it first? Because it serves various purposes like conserving the IP addresses by allowing the multiple device to get a same public IP. Because if there would be no public IP, then there would be definitely certain different IP addresses for each of the end device. Therefore, more IP addresses would be wasted, and also it provides a layer of security so that our own private IP address is not leaked or not exposed to the hackers. Instead, our public IP is being responsible for us, and it is acting as us for the rest of the internet. Now, how it works? So it's a very interesting way of how it works. Now, these are all the you can see that these are all the IP addresses, all the end devices and their IP address. Like for example, for this PC, it is 192.0.0.1. For this mobile, it is zero point 0.2, and for this laptop, it is zero point 0.3. Now, for this router, it is 192.0.0.4. Now, what happens is that whenever let's say this point 0.1 wants to communicate with the rest of the internet, this is the internet. This this basically this PC or this laptop will have or this router will have a certain NAT table. So this is the NAT table. Yeah. So this is the NAT translation table. So on the LAN side of the address, uh, we will be have a we'll have a mapping of all the private IP addresses that want to communicate. So like for example, uh, if the LAN side of this IP address is 192.0.0 because it wants to communicate, and the port number for it would be 2330. So then its WAN side would be 174.27.89.4. This IP address would be the LAN side of the router. Okay, so it would be mapped with the LAN side of the address. Now here there would be a specific uh, masked port number also. Now why masking the port number is important, because let's say for example, uh, so this is the first of all, this is the source and this is the destination, or whatever the destination would be. This is not the destination, but this is the public IP address. So let's say the destination is 197.102.12.2. Okay, and so from that so that would be the destination, and the source would be this one for the WAN, but for the rest of the internet for the public IP address. But if I want to get a data packet back, so I'll receive it on the WAN side. But if I don't get the port number here, if I don't mask the port number here, how will I get to know which device does this data needs to be sent? Because if there's no port number, how would I be able to? Because I'll basically broadcast it, and uh, all the devices would receive the same thing, and that is not feasible because it can be a certain information that is specific to certain device. So that's why we also get the port number here, so that our our devices are safe and only certain part of them are basically representing that, okay, when I get the packet back, this is the port number where I should receive my data back, and this is the port number where I'm sharing it, and my private IP address is now your public IP address, and I can operate through your public IP address. So this is basically the whole idea of DHCP and NAT. Thank you, and I hope you enjoyed this video.